la fête des sciences. C'est la fête des sciences.
Let's go and see Mr. Benjamin's molecular cooking class.
Bonjour, comment t'appelles-tu?
Alexandra.
Qu'est-ce que vous avez fait dans cet atelier?
On a fait une expérience où il y avait des mélanges faits par Monsieur Benjamin réfrigérés et on a dû les mettre dans du sodium et les manger.
Vous avez aimé?
J'ai pas encore goûté.
Merci.
Hello.
Hello.
What's your name?
Maxime.
What workshop are you doing right now?
Cuisine moléculaire.
What is it about?
We had to taste fizz, but we didn't know what the taste was.
How are did you find it interesting?
Yes.
Goodbye.
Okay, so we've got really, really hot sugar here. You're going to take the bicarbonate and we're going to pour it in.
Oh, it's raisin.
You see what's happening?
Yes. So cool.
Science is hip, kids, remember.
And now, up.
Oh my god, that looks so good.
Using
So you can see all the air that's gone in there from the bicarbonate.
On a fait fondre du sucre et on a ajouté du bicarbonate de soude pour faire monter la pâte.
Est-ce qu'elle est bonne la pâte? Je sais pas, j'ai envie de goûter. Demande à quelqu'un. Oh là là, mais ça sentait super bon. Vous avez une idée de qu'est-ce qu'il faisait?
Alors déjà, ça sentait la barbe à papa. Je crois qu'ils sont en train de faire fondre du sucre.
Probablement pour faire du caramel.
Ça a l'air d'être un gâteau.
Enfin, un gâteau moléculaire.
C'est la fête des sciences.
Radio Récré, c'est Radio Récré. Radio Récré, la radio qui grandit avec vous. Radio Récré, la radio qui grandit avec vous.
Hello, Doctor. Welcome on Radio Récré. My name's Elea, and I'm in CZM A.
Hello, my name's Alexia and I'm in CZMD.
Hello, my name's Juliette and I'm in CZM C.
Hello, my name is Ambrosio and I'm in 5e B.
Can you present yourself?
Yes, hello, I'm Dr. Elsa Arcaute. So I'm an associate professor at University College London. I am a theoretical physicist. I did my PhD in theoretical physics in Cambridge, and then I did looking at things related to general relativity and quantum mechanics. Then I moved to Imperial College to look at ant colonies, the behavior of ant colonies and the patterns they did. And after that, I moved to University College London to look at cities. So basically what I do is mathematical modeling of urban systems.
So what did you present to the children today?
So when you do look at all these systems that I just mentioned, like colonies and urban systems, all of them are complex systems that present patterns. And one of the patterns that you observe, which are also observed in nature, are fractals. So today what I try to convey to the students is how you see nature's fractals everywhere and how you can create them through an experiment and also to draw them.
You just said you were going to ask what are fractals.
What is a fractal?
Yeah, no, I haven't said.
What is a fractal?
Yeah, I haven't said what is a fractal. Yeah.
What is a fractal?
Yes, this is a very important question, right? Because we see them everywhere. And what are they and how we can characterize them is something quite interesting. So what I start doing in this atelier is to explain to children that Benoît Mandelbrot looked at nature and he said, oh, actually with the geometry that I have, I cannot explain all these things that I observed. So you can see that in nature you have things that are rough, right? In the sense that they're not smooth curves, but everything has a repeated patterns that looks the same at a very small scale and at a big scale. So you have a simple pattern that is repeated to infinity. But of course, in nature, things cannot go to infinity, and they have to be, delimited to the object that you have.
Do you come to schools often to present fractals?
No, actually, this is my first time. So mainly I do research at the university, and I have a team of postdocs who do programming things and things of the sort. I teach master students and some undergraduates. So this is the first time that I'm teaching fractals to 11-year-old and 12-year-old children. So it was quite tasking, right? Because I'm not used to create presentation and things for children and to do, adolescents, of course. I apologize.
So did you enjoy coming to this school and presenting fractals?
I enjoyed very, very much. And I was so impressed by the level of knowledge that the student had. It was absolutely unbelievable. Many of the master students that I teach, they don't reply to questions and they don't have these insights or these curiosities. But here, I found the students really, really good. So well done, all of you.
Why did you choose this job?
Oh, this is a very important question, right? So why did I choose to become a physicist? So I was very interested in understanding how things work, why we came to be, where we are, how the universe formed, why the brain works, the way it works. And of course, it's very difficult then to have just the one discipline encompassing all of these things. So I chose physics because at the time I wanted to understand where we came from in terms of cosmology and these things. But at present, as I explained in the past as well, I look at biological systems as well. So like ant colonies. And in my current work, I use models of how the brain works in order to explain how cities work. So I chose this job because I'm very curious and I want to have fun in what I do. And I think this job allows me to be as creative as I can be.
How long have you been doing this job?
For a very, very long time. So I think for around 12, 13 years.
Do you find it interesting?
It is very interesting. So the thing about this job, to be an academic and a researcher, that you have the freedom to do and to ask questions, that you want to ask. And it's really about how creative you can be. So you can be as far or you can go as far or as short as you want in this kind of job. So it's super, super fun.
How long have you been interested in science? Since you were a kid, or have you started?
I think I have always been interested in science, but the thing with science, and especially when you look at fundamental science, is that you can also think about things related to philosophy, why we are who we are, and these sort of things. So I have always been very curious at understanding things, but it wasn't as easy. It's not that when I was a kid I knew that I wanted to be a scientist or a physicist. I also wanted to be a photographer, and I wanted to be so many other things. So it was very difficult to choose, the one discipline, and to say, okay, this is what I'm doing, as a career. But it was mainly the curiosity that drove me into it.
Would you change if you could become something else? Or?
That's a very good question, actually. So I was always, in the middle between physics and biology, because I love these things. And I think that actually, if I had the chance, I would have done again physics, because, I have the chance to test things in the way I understand the scientific knowledge.
So do you think you would prefer physics?
Yes, definitely.
What advice would you give to young scientists that are trying to learn physics? Okay, so the first advice I would give to all of you is not to worry if you don't know what you want to do when you are older.
right? So don't worry about it, because you're just learning about, in CZM, you're just learning about physics and biology and all these things. And the way you look at things in science now is very different to how you will be looking at later on. So the first thing is not worrying about, like whether you know or you don't know what you want to do when you're older. But then my advice is to be curious about things, and never, never, never to think that the question that you have is not a good question. Every question is a good question. So you should always keep asking questions and always ask, but why? Why? Nothing is like that because it is like that. There is always a why behind. And in science, we don't have all the answers to all these whys. So keep asking in everything that you're shown, why is this the case?
Thank you so much to have answered all our questions, and hope we see you next year, maybe Science Week.
Well, thank you very much for having me. It was super fun. Thank you. Bye.
C'est la fête des sciences.
Hello, welcome on Radio Récré. I'm Elea in CZM A.
I'm Alexia in CZM-D.
I'm Juliette in CZM C.
I'm Ambrosio in 5e B.
Can you present yourself to...
It's very lovely to
radio?
meet you all. Thank you very much for having me on. My name is Rosie Eade. I work at the Met Office. I'm based in Exeter and I'm a climate scientist.
What's a climate scientist?
That's a very good question. So we try and understand what's happening in our world in terms of the climate. So you all know about weather, yeah? Yes. And that kind of changes fairly quickly, doesn't it? It might be different 1 hour to the next hour. It might be warm today and rainy tomorrow. But climate is about averages. So we do these long-term averages. We kind of sum up what the weather's like over a long time period, so over many years, and then we can tell you what the average climate is. So what do you think the climate is like in the UK in the summer?
Sunny.
Sunny, yeah.
Hot.
It's not necessarily warm. No.
Warm.
A kind of
medium.
warm, medium, kind of.
What about if you were to go to India? What do you think the climate in the summer there would be like?
Boiling.
Yeah, very good. So it's all about these long-term averages. So if you want to go on a hot summer holiday, you will go somewhere nearer the equator where you know on average it's going to be hotter. But actually in the UK we can have some really hot summers, can't we? Yeah. So it's my job to understand all these variations around the averages and try and work out what's going to happen over the next 10 to 100 years.
What sort of things will you be explaining to the children in the workshop?
So this afternoon I will be doing 2 workshops on hurricanes. So although average kind of climate, average temperatures are interesting to people, it's actually the extreme weather that really affects us. So we want to know how many hurricanes are going to hit the USA in the summer, in the autumn, and then people can plan and be prepared. So that's what I'm going to talk about today. But we do lots of interesting research into all kinds of extreme weather, so heat waves and cold waves, the kind of big storms that we get in the UK sometimes. All these kind of extreme weather phenomena is what we're interested in.
Do you enjoy coming to school? Have you ever come to a school before?
I've been to this one before. I came last year. Yeah, I find it really fun because most of my time is sat at a computer at work, and I do lots of maths and statistics and look at how our models are working. But it's really nice to meet people and talk about what we do, and it's nice to escape.
How long have you had this job?
Over 10 years. I've been here a long time. Yeah.
Do you enjoy it?
I do enjoy it, yeah. So I'm really interested in maths. Are any of you guys interested in maths?
Yeah.
Very.
Yeah, oh brilliant. It's a really interesting subject because you can apply it to all sorts of things. So I love that I get to apply my maths knowledge to kind of real situations and hopefully help people, because if we can understand what's changing around in our climate and in the weather patterns, then I figure, we can help people be prepared.
Have you ever had any serious climate
serious climate changes?
Dangerous.
So I'm not involved in any serious sort of events, but as at the Met Office we are involved in warning people. So if there's a serious flooding event or if there's a serious high wind event coming to the UK, then we will work with the Environment Agency and make sure that everybody knows what's going on.
Thank you for responding to our questions, and have a good day.
Thank you.
C'est la fête des sciences.